Hello everyone, my name is Jorge Isaac, and today I'm going to explain my practice called 8-bit binary counter implemented on the DA10 Lite FPGA using Quartus Prime Lite and VHDL. This practice we designed, simulated, and implemented a simple binary counter that uses the FPGA 15 MHz internal clock. The counter increases its value with each clock pulse, and the result is displayed on the board slits. So let's begin with how the program works. So here's the VHDL, the VHD. The entity is called bin count, and it has four main ports. Clock 50 MHz. This is the input clock signal from the FPGA. Reset clock. This is the reset input to restart the counter. Clock out. This is the divided clock output, and the counter. This is an 8-bit output vector that represents the binary count. Inside the architecture, we created two main processes. The first process is the clock divider. It uses a 26-bit signal called clock temp as a counter. Each time the FPGA clock has a rising edge, this counter increases by 1. From this 26-bit counter, we take bit number 26, named clock new, to generate a much slower clock signal around 2.98 Hz. This means one cycle every 0.335 seconds. This time clock is then used to control the binary counter. The second process is the binary counter itself. On every rising edge of clock new, it increases the value of count 10 by 1. This 8-bit value is connected to the FPGA LEDs so we can see the counting visual. When the reset button is pressed, switch is pressed, the counter goes back to 0. So we go to the PhD. So the test bench generates a 15 MHz clock by switching the clock 15 MHz signal between 0 and 1 every 10 nanoseconds. The waveform shows that how the divided clock out toggles at a slower rate, while the 8-bit counter increments on each rising edge. The simulation confirms that the clock, divided, and the counter were working correctly. So here we are. You can see the VHD, and you can see the waveform by going to RTL simulation. So let's go to the pin planner. So here you can see the clock 15 MHz of the FPGA is pin P11. Clock out is our LED B12, which is switch 9. No, LED 9. Sorry. Counter 7, 6, 5, 4, 3, 2, and 1, 0. For the LADS 7 to 0. And our reset clock, we have the switch 0. So once you put these pins, we go to the FPGA programmer. So you click on start and wait until the program is 100% uploaded. And so let's go to the FPGA board. So here you can see the FPGA. You can see it starts, well, it resets itself when it reaches 255 bit. So we go to, sorry, let 0 let as 1, let 1 as 2, let 2 to 4, 8, 16, 32, 64, 128, and 255, or 55. So you can see that the clock is switching and the leads are working, so our practice work correctly. So that's it, and see you in the next video.